Hello and welcome to my video, Indices and Logarithms. Now this is part of the level 2 mathematics course, and the pass criteria is to manipulate and simplify 3 algebraic expressions using the law of indices and then 2 more using the laws of logarithms. So let's show you how to do that. We're going to start with indices. An index number is a number which is raised to a power. The power, also known as the index, tells you how many times you have to multiply the number by itself. For example, 3 to the power 4 means you have to multiply 3 by itself 4 times. So 3 times 3 times 3 times 3, which is 81. There are 3 laws of indices. We're going to start with number 1, which is multiplication. If the 2 terms have the same base and are multiplied together, their indices are added. What this means, if we're multiplying 2 or more values that have an indices, providing they have the same base number, we can simply add their index numbers together. So here I have x equals 10 to the power 3 times 10 to the power 4. A base number is the number which is being multiplied by itself. So in this instance, it's going to be the number 10. So you can see I have 10 to the 3 times 10 to the 4. That means I can add the index number 3 to 4, which gives me 7. It's like I've just squashed that whole line into a single value. So it's just simplified things. Let's have another look at. So y equals 2 squared times 2 cubed times 2 to the power 4 times 3 to the power 5. So 3 is a different base to the rest of it. So that's going to need to stay separate. However, the 2, 3, and 4 can all be added together as a single index for the number 2, which gives me 2 to the power 9 times 3 to the power 5. The second law is division. If 2 terms have the same base and are to be divided, their indices are subtracted. What this means is we're dividing 2 or more values that have an index. Providing they have the same base number, we can simply subtract their indices, the latter from the former. So here I have x equals 3 to the power 7 divided by 3 to the power 4. 3 is our base number. It's the same. So I'm going to subtract the 4 from the 7 to give me 3. Let's have a look at another example. Y equals 10 to the power 10 divided by 10 to the power 2 divided by 10 to the power 3 divided by 5 to the power 2. 5 to the power 2 is a different base, so it needs to be kept separate from all the 10s. So I have 10 divided, I have the 10, 2, and a 3, all being the index numbers of 10. So I can subtract the latter from the former, and I end up with 10 to the power 5 divided by 5 squared. Third law is brackets. If a term with a power is itself raised to a power, then the powers are multiplied together. What this means is if you already have a number being raised to a power and you raise it to a power again, the index numbers can be multiplied together. So I've got x equals open brackets 10 squared, close brackets to the power 5. So I need to multiply the 2 and the 5 to make a new index number for the 10, which is 10. Let's do some proper examples. Example 1, z equals x squared times y to the 5 times x cubed times y to the 6. We're multiplying, so we need your first law. Pause the video, have a go yourself, and we'll see how you've done afterwards. Right, let's see how you've done. So multiplying is the first law. So I'm going to group all the index numbers over the same base, and I'm going to add them together. And then I'm going to solve the inside of each bracket. And then I'm going to simplify. And that's it. Let's try another one. C equals a to the 5 b cubed divided by a cubed b. Here we're dividing, so we need the second law. And we also need to note that b, without a number as the index, is essentially b to the power 1, because anything to the power 1 is itself. Pause the video, have a go. Right, let's see how you did. We're dividing, so we need the second law. So I'm going to collect all the index numbers of the same base together, and I'm going to subtract the latter from the former, which looks like this. I'm then going to solve the inside of each bracket. And then I'm going to divide, and then I'm going to simplify. One more. S equals r to the minus 1 times r to the minus 5. we're multiplying. So we need that first law again. But like I said in the basic principles videos, we need to be very careful about what we're doing with the minus signs. Pause the video, have a go. Right, let's work through this. So it's the first law. So I'm going to add these index numbers together over a single base, which is R. But I'm adding the negative numbers here, which just means I'm essentially subtracting the latter number from the former. So that's going to give me this. And there we are. Let's have a look at logarithms. Now, logarithms will build on this knowledge that indices have. So a logarithm is the power to which a number must be raised in order to get some other number. In other words, how many times we need to multiply a number by itself to get the desired answer. So you can see I've got two lines here. I've got 10 cubed equals 1,000 and 3 equals log to the base 10, 1,000. Now, both these are true and they are equivalent. They're essentially the same thing. Now, I've color-coded the numbers. The red number, the base, is the number we're multiplying itself. And you can see where 10 is my base, that's being multiplied by itself, it's the base of my logarithm. It's the base of my logarithmic function, so it's in the subscript. The blue number is the index, the number of times we're multiplying the base by itself. So it goes from my index above my base on that first line, and it's just a whole number in its own right on the second. If you pop log to the base 10 of 1,000 into your calculator, it would come out with 3. In fact, the log function on your calculator will usually be log to the base 10. So the logarithmic laws, so a bit of a way of why that works. Here are the basic laws when applying logarithms to equations. The log of 1, log to the base x, so that could be any number of 1 is 0. So if you popped in your calculator any number to the power 0, you will get 1. The log of x to the base x is 1. So if you ever see a log where the value in the bracket and the base number are the same, you can just replace that with a number 1. Products, where we have log to the base x of x and y, it's very similar to the law of indices, where I can instead add the log to the base x of y to the log of the base x of z. Quotients, log to the base x of y divided by z. Again, very similar to the law of indices, where I can subtract the latter from the former, and I get log to the base x of y minus log to the base x of z. Indices, log to the base x of y to the power n. This one's a bit different. I need to bring that n in front of the log to the base x of y and multiply it. So this is at level 2, we don't need to understand why this happens. We just need to understand that this is the function that we do, the operation that we make. So the next 2 lines, they're not really laws, they're just conventions that you probably will come across, and I don't want them to throw you off when you do. So base 10, log to the base 10 of x may also be written as just log x. And that's because we use base 10 mathematics for our everyday mathematics. So rather than writing log to the base 10 every single time, sometimes you will just see log x. The natural log, so log to the base e of x. E is a constant irrational number, very similar to pi. It's very useful in maths and science, and in everywhere you look, you'll normally see it written as ln of x, the natural log of x. So example 1, we have x, y divided by 5 equals 10 to the power z. And we're going to simplify this using logarithms. Now 10 is the number with an index. That means it's going to be our base number when I apply a logarithmic function to both sides. And that's going to look like this. Now I need to apply the laws of logarithms to each side to simplify it further. Now, the first thing I'm going to do is I'm going to go on the right-hand side and I'm going to take the z, that 10 is raised to the power 2, and I'm going to multiply it by log 10. Then I'm going to take log 10 of 10, which we know from the laws page is going to be 1 and substitute that in. And then I'm going to look at the left-hand side. I'm going to start with the quotient rule and move that divided by 5 to its own log by subtracting it. And then I'm going to separate the products, the x and the y, by adding them. And that gives us our solution. We can put log to the base 10 of 5 into a number, but it's an irrational number. So this way is neater. Example 2, y equals x e to the power z. Now, e is our base number this time. Pause the video, have a go yourself, and we'll see how you've gotten on. Right, let's see how you've done. With e being our base number, I'm going to take a log to the base e of both sides first. Gives me this. Now I'm going to separate the products on the right-hand side, the x from the e to the power z. And I'm going to do that with addition. And then I'm going to bring down the index number and multiply it by the log e of e. And we know that log to the base e of e is 1, because anything where the base and a number in the bracket are the same is 1. And finally, I'm just going to make this match convention, and I'm going to change the log to the base e to ln. And that's our solution. Thanks for watching. I hope this has helped you understand indexes and logarithms a bit more. And I will speak to you in the next video. Goodbye.